Ben Shaul, for those who don't know me. The Faculty of Medicine, and I study chemosensation, and I'd be asked me to talk to you a little bit about the glomerulonasal system, which you'll know more about at the end of this talk, and a little bit about chemical communication in general. So I'd like to start with the next slide. Working a second ago. So I'd like to start with the sensory organ of the system, which is called the VNO. Have you heard about it? Do you know about it, some of you? Okay. So the VNO is the glomerulonasal organ, and I'll tell you more about it, maybe more than you want to know in the later part of the talk. But what I'd like to say to you now is that it houses the sensory neurons that are the entry point or the first stage of the glomerulonasal system. And I will just use the term VNS for glomerulonasal system because it's a tongue breaker a little bit for me. So this is where the sensory neurons are, and you can see its location. We have a section through a head of a rodent, some generalized rodent. Right here there is this tube, and if we take a coronal section through it, this is what it looks like. So the VNO is a bilateral structure, and later you will understand a little bit more what the different parts of it are. But I'd like to start actually in a way that's a little bit different than what I usually do, and talk about first what happens when we don't have it, or when mice don't have it. And there are several ways in which we can study the system. Of course, you can measure responses and brain regions that receive information. One very straightforward way to study a system is to lesion it and see what happens. Of course, this approach has limitations, but it can also be very useful. And in this system, there are two ways that are used to lesion it. One of them is really an anatomical lesion. You just section the whole organ away, and this can be done in mice, and they can heal, and you can later test them. Another way is to make a genetic lesion. And this is through a specific cation channel that's specific to the sensory neurons in this structure, and if you just genetically knock it out, then only the sensory neurons in this organ cannot function. And both of these approaches have been used to study what happens to mice when they don't have the functional VNO. And so I'd like to make a survey of some of the more interesting and more, I would say, high-profile findings that have emerged from such studies. One of them has just come out very recently from in Nature, from the lab of Catherine Dulac. So one of the first studies that came out
Can you explain a bit about the VNO? What sensor are you talking about?
I'm talking about chemical senses. Sorry, I thought that was not clear. I'm talking about chemosensation, chemical senses. It's similar to the sense of smell, but it's not the normal sense of smell. It's not the usual sense of smell that we have. Well, you'll have more answers to this question, but we're talking about chemosensation, and in mice there are several olfactory systems or chemosensory systems, and I'm talking about this one that's called the glomerulonasal system, the VNS. And I will give more details to this specific question, okay, in a few slides. I'd like to start now with, maybe it's not a good idea, but this is what I want to do in this lecture. First, talk about what happens without this organ, when it doesn't function. And interesting things happen, that's why I think it's worth going over them. One of them is that male mice start being very friendly towards other males. So not only do they lose aggression towards them, they actually start mating with them, okay? So clearly, this has a very important, what? Too friendly maybe, that's what the other mice think, but that's one thing that happens. They also continue to mate with females, so this is not damaged, but they just become less discriminate about what they would like to mate with. And I'm not going to go now over each figure and what it shows, I'll just say that these rasters, they show the incidence of aggressive behaviors, and this is a normal mouse that's aggressive to another intruder male, and this is a knocked out mouse, a mouse with a non-functional VNO that doesn't show the same levels of aggression. Okay. So
why is it relevant that they are frustrated, if I may interrupt?
So they're not. So actually, the test here was there are two stages to this test. First of all, two aspects. One of them is to introduce a castrated mouse to both the knockouts and the normal mice. The castrated mouse doesn't generate aggression usually. So that's the control. And then you put on this castrated mouse some urine from some non-castrated mouse, and that's generating the aggression. The aggression takes place in the normal mice, but not in the VNO lesion mice.
So what elicits the aggression is some component of the urine of non-castrated mice?
Exactly, yeah.
Is it known what this component is?
It is known, so there's several such components. And you can, some of them have been identified. So one easy thing to do is to fractionate urine, let's say to high molecular weight, low molecular weight fractions, and see what elicits aggression. In this specific case, both of them do. Both types of compounds, both types, sorry, of fractions. And when people focused on the high molecular weight, they actually identified some specific molecules that can induce this behavior. So this is one of the clearest cases we have of understanding a compound that does something very specific. And actually, I will mention this class of compounds in this class. Another interesting finding. This is actually was known for a bit longer, but two relatively recent studies came out and explored this again. As without a VNO, males become, in a way, better fathers. So with a VNO, a mouse that is not experienced of being a father, a virgin male, will be very aggressive and might even kill pups of other mice pups. But without the VNO, this does not happen. Without the VNO, the mice lose their natural aggression or infanticide behaviors towards pups. So that's another thing in which the VNO plays a role. Actually, it's not a good role, I mean, if we think about it this way, but it's a role that makes the mouse more aggressive to pups. Could be, of course, pups of some other mouse, for example. And in this way, we might think that it could play some adaptive role. Okay? Here's a very complex slide that shows a very complex behavioral experiment. And here, the experiment was focused on females. So far, I talked about male mice. This is focusing on female mice, again, knocked out in a specific channel that's required for VNO function. And what they saw here are, again, several interesting findings. First of all, these females became hypersexual, not only towards males, but also towards females. So that's similar to what we saw in males. They also became, in a way, worse mothers. So they spent less time with their pups in their nest. This is one thing that is shown. They lost all their maternal aggression, which is something that usually mice have, and is, of course, important for protecting the young. And they were actually, while they were nursing, while they were giving milk to their pups, they were interested in sexual interactions with other males. And that's something that's uncommon for normal mice that do have a functional VNO. So that's another finding, and I know I cannot go over all the different figures. These are just to show you a general survey of what can happen. Another thing, and this is clearly an important factor, is that mice lose, at least in some contexts, their fear of predators. And this is an experiment in which